Children, you see in page number 61, here is a song on matter. Let's recite. Yes, children, there is a song you can see. The three states of matter are solid, liquid, gas. Once again I repeat. Okay. The three states of matter are solid, liquid, gas, solid, liquid, gas, solid, liquid, gas. The three states of matter are solid, liquid, gas all day long. Once again, the three states of matter are solid, liquid, gas, solid, liquid, gas, solid, liquid, gas. The three states of matter are solid, liquid, gas all day long. Take page number 62. Yes, again the song is continuing here. The floor is a solid, you can jump up and down. The floor is a solid, you can jump up and down, jump up and down, jump up and down. The floor is a solid, you can jump up and down all day long. Next one, third one. Water is a liquid, you can drink right down. Water is a liquid, you can drink right down, drink right down, drink right down. Water is a liquid, you can drink right down all day long. Air is a gas, you can breathe right in. Air is a gas, you can breathe right in. Breathe right in, breathe right in. Air is a gas, you can breathe right in all day long. Once again, I sing this song, children. The three states of matter are solid, liquid, gas, solid, liquid, gas, solid, liquid, gas. The three states of matter are solid, liquid, gas all day long. The floor is a solid. Yes, children, here the floor is a solid. You can jump up and down. You can jump up and down also. Okay, the floor is a solid. You can jump up and down. Jump up and down. The floor is a solid. You can jump up and down. Next, children, water is a liquid. You can drink. You can drink the water. Water is a liquid. You can drink right down. Drink right down. Drink right down. Water is a liquid. You can drink right down all day long. Air, children. Air is a gas you can breathe for our respiration. Air is a gas you can breathe right in. Breathe right in. Breathe right in. Breathe in air is a gas you can breathe right in all day long. Okay. See, children, here this song is a very, very special song. In this song, mainly solid, liquid and gases are divided. In the first case, yes, the floor is a solid. If you jump up and down also, nothing will happen. Okay, that is why you can jump up and down. Jump up and down is given. Next, water. Water is a liquid. Water is a liquid. You can drink right down. Yes, we should drink the water. Okay, gas. Next, air is a gas. You can breathe right in. Breathe right in. Breathe right in. Air is a gas all day long. All day long. Okay. Children, now see the solids, about the solids. See here, solids have a fixed volume and shape. First point, solids have a fixed volume and shape. Solids have a fixed volume and shape. Children, here see, volume. What is volume, children? See, children, you have small water bottles, you have big water bottles, and you have very big water bottles. That means if you will observe the small water bottle, the volume is less. In big, it is somewhat more. In very big, it is more, much more. So here in cool drinks also you can observe like 300 ml, 500 ml, 1000 ml, it will be written like that. So this ml is indicating the volume. And here solids have a fixed volume, children. Solids have a fixed volume. This ml is it is in the case of liquids, but is in the solids you can the volume. See, this volume is the volume here. Okay, length into breadth into height. Length into breadth into height is the volume. Length, you can see the length. Okay, see here length. This is a breadth and a height. Okay, so the three areas, length into breadth into height. So it is fixed volume here. The volume of a solid is fixed and the shape is also fixed. See, this book is in the shape of rectangle. Some are square shape, some are circle shape, like that. So here the volume and shape is fixed. The volume and shape is fixed, children. And next one, if you go for the second one, in solids, the atoms or molecules are in fixed positions relative to one another. In solids, atoms or molecules. In solids, atoms or molecules are in fixed positions. Are in fixed positions, children. They are in fixed positions relative to one another. That means they won't change. For example, if you take a solid, this is an atom. Here, see. These atoms or molecules are very close to each other and there is no space also here. So here the atoms or molecules are in fixed positions. They are in fixed positions relative to one another. They are in fixed positions relative to one another, children. Okay. They vibrate but stay in relative position only. You can say the phone vibration. If your phone is a solid, yes, they will vibrate. They will look like this. The solids vibrate, but they won't go from here to there. So that is the thing. Next one, when the solid is heated, the atoms vibrate faster. When the solid is heated, the atoms vibrate. The atoms vibrate faster, children. Usually, what I told just now, solids vibrate, but they won't change in the same position only. The atoms will vibrate in the same position, but they won't change their positions. And one more thing, the solids, when the solid is heated, you can feel more vibrations. Atoms vibrate faster. The atoms vibrate faster. This causes the solid to glow slightly in size. Yes, children. When you heat the iron, you can see the expansion. Size. Okay. You can see the increase in the length. Why? Because when you will heat, the atoms vibrate faster. This causes solid to grow slightly in size. It is said to expand. What is that, children? That is called as expansion. expansion. It is said to expand. All solids expand on heating, especially metals. Yes, children. All solids expand on heating. All solids expand on heating, especially metals. All solids expand on heating, children. Yes, see. All solids expand on heating. All solids expand on heating, especially metals, children. Children, just now I told you that why solids expand on heating. Yes, when you apply heat, what happens there? The atoms will vibrate very faster. When they will vibrate very faster, you can see, for example, the length is this one only. When you will apply flame here, automatically you can observe there will be increase in the length. Children, I told you about the solids. Solids have fixed shape and fixed volume. And when the solid is heated, what happens, children? Yes, it expands. Here see, railway lines can buckle on hot days. You can see on hot days means especially during summer days, railway lines can bend because of expansion. Because of expansion. And metals are crystalline. They are like crystals because their atoms are arranged in a regular sequence. Children, a regular sequence. Regular sequence means if you see here like this, like this, like this. This is a regular sequence, children. This is a regular sequence. Okay. So, the metals are crystalline. They are like crystals because they are arranged in a regular sequence. Atoms of metals tend to have loose electrons. So, children, you might have got one doubt. Sir, what are these electrons? Yes, I'll tell. For example, this is an atom and atom has, the center one is called as nucleus and electrons revolve around the nucleus. Every atom you take either in the solids or in the liquids or in the gas, these electrons are present. And atoms of metals tend to lose. What happens here? They lose the electron. They lose the electron. When they lose the electron, okay, between, here see, these electrons can move between atoms. These electrons can move between the atoms. This is one atom and this is another atom. So, in between the atoms, the electrons can move. This causes metal to conduct electricity. So, here, how the metals can conduct electricity? Because of losing the electrons. When they lose the electrons, these electrons will be gained by another atom. So, when any metal can lose the electron, this electron will be gained by another metal. So, this is how the electron will be shifting between the atoms and conducts electricity. Conduction means passing of the electricity, generates the electricity, conducts the electricity. Once again I repeat about the solids. Solids have a fixed volume and shape. I told you about the volume, length into breadth into height. Okay. And it has a definite shape, children, like a square, like a rectangle, like any oval or egg shape, whatever the shape. Solids have a definite shape and volume. And in solids, atoms are in a fixed positions relative to one another. They are in fixed positions. Yes, the atoms in the solids can vibrate, but in the same position only. They won't change from one place to another place. And next one, they vibrate, I told you, but stay in relative position only. When the solid is heated, atoms vibrate faster. Here see, when solid is heated, atoms vibrate faster. So due to this, there will be increase in the size while heating. Okay, that is called as expansion. That is called as expansion. Railway lines can buckle, that means they bend on hot days during summer because of this expansion only, children. Metals are crystals. They are like crystals because the atoms are arranged in a regular sequence. And one more property of these metals is they tend to lose the electron. When they tend to lose the electron, these electrons are gained by another atom, and these electrons will be shifted between the atoms and conduct electricity. Conduct electricity. So this is about the solids, children. Okay. Right. Now coming to the liquids, children. In solids, you have observed that the molecules are close to each other. The molecules are close to each other. That means the space between the molecules is very less. But this is in the case of solids, children. In the case of liquids, the distance between the molecules is more. This means space is there. Right. And you have learned that solids have fixed shape and volume. Let's come to the liquids. Liquids have a fixed volume. Liquids have a fixed volume. Like if you go for the cool drink bottles, you can observe small PET bottles, medium sized bottles and large bottles. If you will clearly observe, in that the volume is mentioned like 250 ml, 500 ml, 1000 ml. 1000 ml is nothing but 1 liter. That means it has a fixed volume. Can we tell the shape of the liquid? Exactly. Very good. We can't tell the shape of the liquid exactly. Then what is the shape of the liquid? If you pour some water in a glass, what is the shape of that water? Glass shape. If you pour the same water in a round shaped bowl, what is the shape of that water? Round bowl shape. If you will pour the water in a square box, what is the shape of the water? It goes to square. That means liquids occupies the shape of the container. What is container? These bottles, these pots, these glasses, all these are containers. Once again I repeat, liquids have a fixed volume but take the shape of the container. Atoms move. Here see, atoms move in liquid. In liquids, atoms move relative to one another. No doubt. Here the atoms move relative to one another. That means they glide each other. They glide each other, but they still stay close together. They glide each other, but they still stay close together. Next one, you see, liquids can only exist for a limited temperature range. The best example is water. What is the boiling point of water? At what temperature the water will become gas? Above 100 degrees. So water is liquid for only 100 degrees Celsius. Above this, it will become gas. For most temperatures, the liquid, okay, is either a solid or a gas. It is either a solid or a gas. Okay. Let's go for the pressures, children. What happens at low pressure? Children, what is pressure? In physics you have learned force per unit area. Force per unit area. Here see children, this is my arm. If I will apply pressure here, okay, this is the force and this area, force per unit area. Here see this area. Force per, this is the area where I am applying the pressure. Okay. So that is called as pressure. What happens to the liquids at low pressure? How they behave? How the liquids behave at high pressure? At low pressures, the range of temperature for a liquid to exist is smaller. At low pressures, the range of temperature is small. At low pressure, the range of temperature for liquid is smaller. That is why water boils at less than 100 degrees centigrade at high altitudes. At high altitudes. Altitudes means heights. Okay, as you go high, at high altitudes, water boils at less than 100 degrees centigrade. Water boils at less than 100 degrees centigrade. Okay, water boils at less than 100 degrees centigrade. That means at high altitudes means children, as we go high, okay, as we go high, water, what is the boiling point of water? 100 degrees centigrade. But here, as we go high, even the water boils at less than 100 degrees centigrade also. Okay. So once again I repeat, at low pressure, the range of temperature for a liquid to exist is smaller. That is why water boils at less than 100 degrees centigrade at high altitudes. If the pressure is low enough, the liquid phase does not happen. If the pressure is low, very low, if you go on decreasing the pressure, you can't find the liquid phase. Okay. So once again I repeat this, at low pressures, the range of temperature for a liquid to exist is smaller. That is why in the high altitude, even the water boils less than 100 degrees centigrade. If the pressure is low enough, the liquid phase does not happen. If the pressure is high only, the liquid phase happens. If the pressure is low enough, the liquid phase won't come. So from this paragraph, it is clear that at low pressures, the range of temperature is small. That is the reason at high altitudes, what happens? As you go high, the pressure decreases. Okay. So automatically the water can boil even less than 100 degrees centigrade. If the pressure is low enough, the liquid phase does not happen. A pure liquid contains only one substance. Most liquids dissolve other substance. Yes, this is very important, children. Pure liquid contains only one substance. If you take water, it's pure. Okay, but water can dissolve so many things. Most liquid dissolves other substance also. The liquid is solvent and the substance being dissolved is solute. Yes. Here see, for example, sugar plus water. Sugar plus water give rise to sugar solution. Sugar plus water give rise to sugar solution. So see children here, what is going to happen? So if you can dissolve 2 or 3 spoons of sugar in water, 2 or 3 spoons of sugar. So sugar is mixed with water, you will get sugar solution. Here sugar is taken little, whereas water is taken more. So the quantity which we take less is called solute. The quantity which we take less is called solute. The quantity which we take more is called solvent. Okay. The quantity which we take less. See children, in sugar solution, we take more water, less sugar. That is why it is solute. More water, that is solvent. Solute plus solvent gives solution. Solute plus solvent gives solution. What is solute children? The quantity which is taken less is called solute. The quantity which is taken less is called solute. The quantity which is taken more is called solvent. Solute plus solvent give rise to solution. Solute plus solvent give rise to solution. Okay.